Critical design review for the retractable keel by the hard workers. So our problem statement: in water vessels across the U.S., uncontrollable conditions cause recreational boaters to capsize. In fact, according to the U.S. Coast Guard, there were 234 capsizing boat accidents that resulted in 121 deaths and 103 total injuries in 2022. So for our design specifications, we were targeting recreational boaters that experience rough waters when doing various recreational activities with their recreational vessels. So what we want in our product is something that's versatile, that fits on most type of boats. We want it to be retractable, the keel to be retractable. We want it to be functional, so it actually prevents the boat from capsizing. We want it to be detachable, and we want it to be aesthetically neutral slash appealing, so that people don't hate the way that it makes their boat look. And we want it to be between $200 and $400.
Our final brainstorm solution is a retractable keel. Our survey responses show that many people would be more likely to purchase the retractable keel than any other of our solutions. This product will create a way for consumers to modify their boats in ways they previously couldn't without using some permanent modification. So it's a good opportunity to change the marketplace. For our final design prototype, we decided to use three main parts: a bridging circle that connects the bottom of the vessel and a secondary circle that connects to a bridging circle, allowing for rotation. We then connected the keel to the secondary circle using screw inserts. This is our current physical model, which includes the secondary circle along with screw and brass inserts in order to connect the keel to the secondary circle. This is our secondary circle on-shape model. The top left image shows the secondary circle connected to our bridging circle. The bottom left image shows an overhead view of what the part looks like, and we also included an on-shape drawing of the part. For our final design procedure, we first had to 3D print the needed parts. We also needed to waterproof the parts because 3D print filament absorbs water. After this, we were able to assemble the parts, and currently we are testing the usability and the ability to incorporate new parts, including a servo and extra needed weight to the keel.
So for our next test, we had to determine how well the retractable mechanism worked just in the scaled down version because we couldn't incorporate it into the alpha prototype. Basically, all we needed was a button, two servos, one 220 ohm resistor, an Arduino Uno, and 11 male-to-male wires. We just connected it so that the Arduino controlled the servos through pins and not just through a direct wired connection from the button. So to explain the code just real quick here, in the loop function, after everything has been defined, the loop function determines if the button has been pressed, and if the button has been pressed, it determines if the keel is in the extended or retracted position, and it calls either the lift or drop function in respect to whichever way it is. So if it's retracted, then it will call the drop function to drop it. So this is just a quick physical look at it. It's a little crazy, but you get the gist.
In order to test our final design prototype, we filled a clear bin with water and used a camera to film the water line. We then placed the prototype attached to the scaled-down version of a boat in the water. We dropped a ball 3 feet from the water line into the water and recorded how much the prototype made a difference.
So here's a video of use with and without the keel. So this is without the keel. As you can see, the boat rocks a lot more and is a lot more turbulent. And this is with the keel with the weighted tip, and this is a lot less turbulent. Now here are the videos on top of each other, and you can see how much less the weighted keel rocks.
So to conclude the keel testing, we will talk about some flaws and solutions. Flaw number 1 is that the keel floats upwards when submerged in water. And a solution to that would to add more weight to the tip of the keel. Flaw number 2 is that the keel does not stay in position. And a solution for that would to create a locking mechanism for the full-scale product. And the last flaw is that the secondary circle does not stay connected to the bridging circle. And for this, we could just use a magnet to connect. And the two circles, they're just part of the detaching mechanism, so you can take the keel off of the boat. And onto the risk, schedule, and budget. So we need to incorporate waterproof materials and servos so that it can work underwater. Our servo must not be too bulky so that it reduces resistance. And for our budget, we believe that it will end up being around $100, but we do not know yet because we have not ordered the materials for the full-scale product.